I have a troybilt Mustang RZT 50 inches. PTO suddenly stopped engaging. Changed PTO switch, same result. Changed the PTO clutch, same result. I believe it may be a safety switch. I tested voltage at connector switch before replacing clutch, and the switch was providing 12 volts when pulled to the on position.
Hello, and thank you for choosing JustAnswer. I'll be helping you today and am committed to providing clear and concise answers to your question. How many volts to the nearest tenth is your battery putting out, please? If you take a voltage reading off the two blue wires when you disconnect them from the clutch and engage the PTO, what reading do you get there?
12 volts.
If that's accurate, that may be the problem then. Since 12.06 volts is 50% discharged. There was no tenth of a volt showing. Are you certain your meter is accurate? As a different test, what if you jumper directly from the battery to the clutch? Does it engage?
Rick, the switch reading measures between 12.18 to 12.25. It bounces around a good bit. If I bypass the switch and wire the clutch direct to the battery, the PTO engages and the blades turn. What does that mean? Buck.
Then something between the battery and the clutch is either resisting voltage, such as a switch going bad or a wire that's corroded or damaged, or there's a minor short. And just to be sure, we're not overly interested in voltage coming out of the switch at the moment. While it's very important, the big thing is what's the voltage reading directly at the connector at the clutch itself when you remove the connector from the clutch and activate the PTO. My hunch is it will be less than what you're getting out of the switch. If it is, we know the problem lies between the switch and the clutch. With electrical, it's usually chasing the voltage drop to see where it's good and where it falls off. What's between those 2 points is where the problem is, so we start at the beginning, battery, and the end, clutch, and then keep working our way back to find out where the voltage is being lost to define the failed component or area of wiring.
Rick, all you are saying is there is a wiring problem. With all new parts I knew THST. This doesn't tell me anything. What does the voltage need to be to drive the clutch? I measured at the connector that separates just 10 inches before the clutch. Isn't that where you wanted the measurement taken?
Sorry, I was reading where you said, the switch reading measures between 12.18 to 12.25. So I was wanting to verify it was actually at the connector. You need a 75% charged battery to drive the clutch, and it really is more about amperage, at least 10A for most clutches, than it is voltage. Here's a chart for battery charge status, voltage versus state of charge. 12.6 plus equals 100%, 12.5 equals 90%, 12.42 equals 80%, 12.32 equals 70%, 12.20 equals 60%, 12.06 equals 50%, 11.9 equals 40%, 11.75 equals 30%, 11.58 equals 20%, 11.31 equals 10%, 10.5 equals 0%. If you're still telling me the battery hook direct engages the clutch, but when you connect the wiring it doesn't, then as I said, something between those 2 points is eating the voltage. I still do not find a supplied answer to my very first question: how many volts to the nearest tenth is your battery putting out, please? If you take a voltage reading off the two blue wires when you disconnect them from the clutch and engage the PTO, what reading do you get there? Is there a voltage difference between what you read at the battery and what you read at the connector? If so, what is it? Then, what perhaps I didn't explain so well, is that you start systematically working your way through the circuit, starting from one end or the other, looking for voltage differences with your meter. I usually split the circuit in two and try it halfway in the middle. If I have good voltage there, I know it's in the second half of the circuit. If I don't have good voltage there, I know it's in the first half. Whichever half it's in, I split it in half again, doing the same thing until I find out where the voltage drop is. Whatever is between good voltage and voltage drop, wire, switch, relay, etc., is the bad part by process of elimination. Does that make more sense? It's a matter of systematically moving through the system. Do you have the schematic from your owner's manual? If not, I can post one that might make it easier for us to discuss exactly where to check. But the process is to follow the voltage and look for where it falls off.
Battery is putting out 12.68 and the two blue wires at the connection are reading 12.24. What does it need to be at the connector to drive the clutch? Second request for that answer, and you have not addressed my initial question regarding the safety switches. They come into play between the battery and the blue connector. No, I do not have the schematic.
I answered that previously, but perhaps you overlooked it or it didn't properly post. Here it is again. You need a 75% charged battery to drive the clutch, and it really is more about amperage, at least 10A for most clutches, than it is voltage. Here's a chart for battery charge status, voltage versus state of charge 12.6 plus equals 100%, 12.5 equals 90%, 12.42 equals 80%, 12.32 equals 70%, 12.20 equals 60%, 12.06 equals 50%, 11.9 equals 40%, 11.75 equals 30%, 11.58 equals 20%, 11.31 equals 10%, 10.5 equals 0%, so you need about 12.35. But 12.24 would probably get some action so long as you have sufficient amperage. It's not merely about volts, but how many electrons are being pushed by those volts. I'm going to post instructions for how to test that below. Instructions as far as the switches, I already addressed that as well. Perhaps it didn't post to the site for some reason? Here is again. Then, what perhaps I didn't explain so well, is that you start systematically working your way through the circuit starting from one end or the other looking for voltage differences with your meter. I usually split the circuit in two and try it halfway in the middle. If I have good voltage there, I know it's in the second half of the circuit. If I don't have good voltage there, I know it's in the first half. Whichever half it's in, I split it in half again, doing the same thing until I find out where the voltage drop is. Whatever is between good voltage and voltage drop, wire, switch, relay, etc., is the bad part by process of elimination. Here's a schematic we can use for discussion. If perhaps I'm overlooking anything in your questions, or I'm misinterpreting what you are looking for, please just ask for clarification and let me know how I can help. I'm willing to assist in pretty much any way possible so long as I know what you need. I'm not sure what I've not addressed regarding your original safety switch question since I've explained how and where to test them. If something is unclear, please just ask. If you need help such as where to put the probes or similar, just request clarification and I'm happy to explain to the best of my ability.
Yes, I need clarification on where to put the probes to test the safety switches and how to interpret the reading to know if the switch is good or failing.
Place the black probe to ground, making sure it's touching bare metal. Clamping it to the engine block is really good, especially if you have to have the probe ends with alligator clips. Place the red probe on first one side of the switch, closest to the battery, to take a reading, then do the same thing on the other side of the switch, furthest from the battery. When you do this, make sure all switches before the switch you are testing, coming from the battery side, are activated. For example, you would test 1. Red wire, Run, leaving key switch with switch in run position 2. With key switch in run position, check terminal 1 of PTO switch 3. With key switch in run position and PTO switch on, check terminal 4 of PTO switch 4. With key switch in run position and PTO switch on, check blue wire going into each of the 2 reverse switches 5. With key switch in run position, PTO switch on, and reverse switch closed, not in reverse, check blue wire coming out of each of the 2 reverse switches 6. With key switch in run position, PTO switch on, and reverse switches closed, not in reverse, check blue wire going into electric clutch when you see a voltage drop or disappearance. What's between what just tested good and what's testing bad is the problem. Could be a wire, switch, etc. This will step through that entire part of the circuit systematically. Something to be very sure of is the ground wire from the negative post of the battery to the frame. If you have a loose connection, bad cable, corrosion, etc., you can lose ground and it will affect all the circuits. The PTO circuit and starting circuits are usually the ones to show up as a problem first when this happens, since they draw the most amps. And I really recommend the amperage draw test in the attachment I sent in my last response, since you can have sufficient voltage, but a weak battery that is drawing down. Another good test if you can't do the amp reading is to read battery voltage at rest, then jumper the clutch to activate it and see what the battery voltage does. If it drops more than 2 volts, it indicates a problem. That's what we call a shade tree poor man's load test, but it works really well, and it often quicker and easier than hooking up a load tester to the battery of doing an amperage draw test. It doesn't tell as much, but it sometimes tells enough.
If you have a home improvement or appliance question and want to chat with an expert now, visit justanswer.com/YTHI.